All right, so we're going to talk about radian measure today.
I gave him on the table.
Okay. All right. So, in geometry, I would say maybe all of the angles that you worked with in geometry were in degrees. And in algebra 2, you learned some things about radians, but I still think you might have went back and forth. We're mostly going to talk about angle measurement in radians. So just a refresher from yesterday, we're thinking about angles as rotating a ray that begins at the positive x-axis and then rotates around. This rotation direction is a positive angle. We can also have negative angles that rotate in the other direction, rotate in the clockwise direction. I don't think we talked about that yesterday. So the direction of rotation could be positive or negative. All right. Also, you can have an angle that rotates around more than one time. So, for example, this angle could rotate this way and end up being that same terminal ray. Different angle, but the same initial and terminal rays. And so, because these, you can consider them to have periodic behavior. And so, anyway, those angles that start and stop at the same place are called coterminal angles. And we'll talk some about that today. They are different angles, but they have the same beginning and ending ray. And so we're going to talk about measuring angles in radians. And at first, it might feel strange, like a strange unit of measure, but hopefully, we'll practice it enough that you can start thinking about angles in radians instead of thinking about angles in degrees. And to get an angle in radians, what you do is you take the arc length of that angle and then divide it by the radius, and that gives you the angle in radians. And just a refresher to if we had an arc length around the whole circle, that's the same as the circumference of the circle. And to find that, it's 2 pi r. Okay, so let's do some angle measurements in radians. So we have this circle that's centered at the origin, and we are going to graph and find the given angle in radians. So we're going to start with a full revolution. I can't remember what that Greek letter is. I want to say it's Omicron, but I'm not sure. It doesn't matter. It just stands for that angle. So a full rotation is going to be 2 pi r. And if I want to write this in radians, I would just divide it by the radius. So what does that end up being? 2 pi. So a full revolution or a full rotation is going to be 2 pi radians. See if I can draw that. Not really. All right, so I'm going to label that over at the angle terminal ray also. Did you guys know that already? A full rotation was 2 pi? You might have learned that in Algebra 2. I hope you did, but it's okay. I'm going to pretend like you don't know anything from Algebra 2 about angles. Okay, let's do half rotation. You probably could use logic and figure out what a half rotation is, but let's just go ahead and do the formula where we take the arc length. So it's a full rotation times half will give you the arc length. And we would divide that by r. And then just like on the previous one, the r's are going to cancel out. And that's going to be pi. So a half rotation is going to be pi radians. And that's angle alpha. Okay, let's keep going. Let's do a quarter of a rotation. So we take the arc length, which is going to be a quarter of 2 pi r, and divide it by the radius. So if I multiply that, I get 2 pi over 4. What should that reduce to? 1/2 pi or pi over 2? All right, I'm going to go back. I'm going to graph beta. All right, and then 3/4. Any guesses what that's going to be? All right, that's good. So we'll take the 2 pi r, multiply it by 3/4, divide it by the radius. So it's going to be 6 pi over 4, or 3 pi over 2. That's going to be gamma. So those 4 angles are probably going to be the first 4 that you just memorize and you know what they always are. So eventually, hopefully sometime next week, you'll have those 4 memorized plus 3 more in each quadrant that you just know exactly what that angle looks like. It might take a little while. All right, so let's talk about an angle that's not like a quadrant angle. We're going to have a 1/12 of a revolution. All right, so that's going to be pi over 6. So I'm going to graph it up there. We're going to rotate a 1/12 of a revolution. I'd say it's about right here. And that's going to be theta. So pi over 6 is kind of considered a special angle in radians that we're going to work with quite a bit. And so on example 2, we have this pi over 6 angle that we just found. And we're going to find some other angles that are multiples of pi over 6. All right, so in this situation, this angle is pi over 6. And these other angles are found by doing reflections over the x-axis, y-axis, and the origin. So this space right here is pi over 6. And so is this angle just to the x-axis. This angle right here is pi over 6. But what we want to find in a second is what this angle is. All right, I'm going to call that alpha. Right, so what was a half of a rotation? So I remember, this is pi. All right, so I know that from here to here is pi. I know that this little section is pi over 6. I want to find from here to here. So what would you do? Good, you would subtract. So for point Q, we're going to call that angle alpha. And we're just going to take pi and subtract the part that we don't want, which is pi over 6. Now I know one person in here likes fractions. The rest of you, I don't know, but this isn't too bad. We need to write these with a common denominator. What would it be? 6. 6 is the only denominator there is. And so 1 is the same as 6/6. And so that angle alpha is going to be 5 pi over 6. So you find a common denominator and then just go ahead and add or subtract the numerators and leave the denominator the same. So that's alpha. I'm going to label it up here, 5 pi over 6. All right, we're also going to find beta. That's going to start at the positive x-axis and rotate to the line that has Q. So what are we going to do this time?
We're gonna add it to what pi?
Very good. So we go all the way to pi plus more plus that pi over 6. So for r, we're going to call that angle beta. It's going to be pi plus pi over 6. Or 6 plus 1, 6, 7, 6. All right, and then finally for s, circle's not big enough. We're going to call that gamma. All right, so remember that full rotation is 2 pi plus 2. So I don't want to do a full rotation, but almost. That's not gamma. Plus 2. We're going to do the full rotation minus the pi over 6. All right, so 2 is going to be 12/6. All right, so those are 4 super common angles that we're going to work with this year. So getting an idea of what they look like, what quadrant they're in, is just gonna, what we're doing right now is like really prepping you for the rest of the year and just being able for it to go smoothly. So there are 2 other special angles, is pi over 4 and pi over 3. So on your worksheet, you're going to do the same situation with those 2 angles, so to kind of get an idea of what they are going to look like. Because we haven't done that yet, I have just some things to help you as we go through the notes. But as you do your homework, what we're doing in the notes is probably going to seem a little bit easier. So we just did pi over 6. So any special angle, any angle pi over, that's a multiple pi over 6 is going to be also special. And the multiples of pi over 6 are going to be graphed closer to the x-axis. So if you look at the ones we just did, if you're comparing the angle, if it's closer to x or y, it's definitely closer to the x-axis. All right, the multiples of pi over 4 are going to be graphed exactly between the x-axis and y-axis. So what angle in degrees do you think that corresponds to? One that would be exactly between 45 degrees. So when you're graphing one of the pi over 4 angles, you kind of think about 45 degrees. When you're graphing one of the pi over 6, you kind of think about 30 degrees. That's what it corresponds to in degrees. And then pi over 3 is going to be graphed closer to the y-axis. So on those, the pi over 3 corresponds with 60 degrees. All right, so on example 3, 4, and 5, we are given some information in what quadrant the angle falls in, and we're going to pick which angle it's going to be, and then we're going to graph it. So do you guys remember how the quadrants go? They go like a C, yeah. So this is quadrant 1, 2, 3, 4. Right, and then I'm going to go ahead and label, I call them quadrant angles because they land on an axis. So an angle that has no rotation at all is 0. And then we determined that this was pi over 2. If you want to think about it as decimals, I know some of you like decimals better. You can think of it as 0.5 pi to do what we're doing today. All right, this is going to be pi. This is going to be 3 pi over 2, or as a decimal, 1.5 pi. And then a full rotation is 2 pi. So 0 and 2 pi are coterminal angles because they start and stop at the same place. But 2 pi is way bigger. All right, so example, this wording it repeats, so I'm not going to read it every single time, but I'll read it the first time. So we're going to let theta be an angle in standard position whose terminal ray intersects a circle centered at the origin at point P. If point P is in quadrant 2, which of the following could be theta? And then we're going to graph theta. So we have to figure out which one of these angles is going to fall in between pi over 2 and pi, or fall in between 0.5 pi and pi. What do y'all think? Or 0.5 pi and 1 pi. That's going to be B. That's like 0.75 pi, which definitely falls in between those. So we're going to draw this in quadrant 2. And for pi over 4, we just said that pi over 4 angles are going to be exactly in between. So we're going to try our best. Obviously, we can't be perfect. That's going to be P. And that angle is going to be theta. All right. And then for example 4, kind of the same situation, but we have point Q is going to be on the circle, and we want our angle to be in Q and our angle to be in quadrant 3. So looking at these, quadrant 3 is going to fall in between 1 pi and 3 pi over 2, or 1 pi and 1.5 pi, if you're thinking about decimals. It's going to be A. So 4/3 is 1.33333. That's 1/2, 0.5. Obviously, that's not going to be it. This is 0.75. That's not going to be it. It has to be something bigger than 1, but less than 1.5. When we get to this one, it's 1.6. So it's going to be A. So let's graph it. All right, so we said that the pi over 3 angles are going to be closer to the y-axis. So we're going to draw an angle in quadrant 3 that is a little closer to the y-axis. That is going to be Q. Well, we'll do it on the outside. And we're going to call this angle beta. All right, so one more. So this last one is going to be angle beta. I think there is a typo. No, this last one's going to be angle alpha. I used theta twice, so that front of the question mark should be another alpha. This is going to be point R on the circle, and we want it to be in quadrant 1. So these negative angles just means there was a rotation that was clockwise. So instead of rotating like we've been rotating, we rotate this direction. And so I have an idea of what pi over 6 is, because we did some work with pi over 6. So this is going to be pi over 6 rotated in this direction. Is it going to make it back to quadrant 1? Definitely not. Now, if you want to know what that angle is, if you have a negative angle and you want to know what the positive version is, all you have to do is add 2 pi to it. So if I took negative pi over 6 and I added 2 pi, which is going to be 12 pi over 6, that's going to be 11 pi over 6, which is not the answer. Those are going to be coterminal angles, and they're both in quadrant 4. So I know it's not those. I'm fairly certain it's also not D. So let's just double check C by adding 2 pi to it. And I do get an angle that's in quadrant 1, pi over 3. So that's the answer. And then we need to graph it. So I'm going to graph closer to the y-axis in quadrant 1. That's going to be point R. Now be careful. When we do our little direction swervy thing, we have to rotate in the other direction that we have been. So we're going to start the positive x-axis, but we're going to rotate this direction So be careful. And that's going to be alpha. So from here to here is pi over 3. That wasn't the answer to the question. All right, are you guys okay? I can't tell. Hope so. All right, we're almost done. I know we're running out of time. These last ones, we're going to do some sketches. So these first three aren't too bad. Pi over 3, what quadrant is that going to be in? Quadrant 1. Is it going to be closer to the x or y or in between? Good. And since it's a positive angle, we're going to start at the positive x and just rotate around like the quadrants rotate. All right, what about 7 pi over 4? You know what quadrant that's in? Okay, if you're not sure, it's okay. So we can take 7 and we can divide it by 4. So it goes. So I'm not going to go to the final answer. I know for sure this is 1.5 pi. If it's between 1.5 pi and 2 pi, it's going to be quadrant 4. If it's between 1 and 1.5, it's going to be quadrant 3. So is this going to be closer to x, y, or in between? In between. So quadrant 4 directly in between. That's theta. All right, what quadrant is C going to be in? 4. For rotating negative pi over 6, it's going to be rotated this direction just a little bit. Is it going to be closer to x, y, or in the middle? X. And then a negative rotation. Okay, one more. Do you guys know what quadrant this is in? 11 pi over 4? It is. Some people in my last class just figured it out. Like they knew that 12 pi over 4 was 3. 3 pi is going to be this much. And so they knew it was going to be a little less than that, which I thought was brilliant. If you are not sure if you need to do something with it, if I take 11 and I divide it by 4, if you get something bigger than 2, then this is going to be a multiple rotation situation. And so what I would do, I don't know, because how my brain works, I would just go ahead and subtract the 2 pi from it. So you're finding a coterminal angle that's going to have the same terminal. It's going to fall in the same quadrant. So 3 pi over 4 is in quadrant 2, halfway between. But be careful when you do your swirly because this goes all the way around and then back to that. If you just do this much, that's 3 pi over 4. That's not 11 pi over 4. Okay. Now I know radians is kind of weird, but you're gonna get good at it as long as you try.